Good evening. I ordered several different metal detector kits from AliExpress, and this is just one of them. I call this the round green one as opposed to the square blue one. But this is actually EQ Kit MDS-60. No big deal. It doesn't come with directions. Costs about $1.85 delivered. So here's all the parts. It's a pretty simple design. Of course, a metal detector needs a buzzer. That's a piezoelectric. Has 3 transistors, a power connector, a variable resistor to adjust the sensitivity, 1 electrolytic capacitor, 3 resistors, 4 ceramic capacitors, an LED, and a push button. And that looks like an on-off switch. So, very simple system. I wanted to play around with these to see how sensitive they are. I think the electrical circuit of this one and the blue one are the same circuit. I'll have to diagram those out. But first step is to identify the resistors. Okay, how the kit works is you identify the value of the component and you find that value on here. For example, there is a C1 with a 104, a C4 with a 104, C3 is 222, so that would be the markings on the part. Now these don't have markings, but they have values. So here's a resistor, R3, 470 ohm. There's R1, 20K. So you measure this, get the value, match it to the board, put it on. Now there's 2 ways to get the values of the resistors. You can get the color code chart out and start deciphering that, or you can just get you a multimeter and test. Start with the dial on 2K, and I simply attach the leads. So that's too low. So that is 2K. So let's see if there is a 2K. 2K. R2 is 2K. So pre-bend the leads. Straighten them out. Very flexible wiring. So you get those as straight as you can. So you bring them down at right angles. That's the best way to put them on the board. And there's 2K. So I simply insert the part. Press it in. And you see the back crosses. Well, bend those back. When you bend those back, it keeps it in the right position on the front. And then keeps that in place, so you just solder that and you go on very quick. So let's go to the next one. Next resistor is, I'll turn down the scale to 2K, 470 ohm. So I'll bend the leads. There is 470, so I simply put it in the holes. Hold it in. I'll get it all the way in first. Hold it in, bend the leads. Very simple. One more. Oops, need to up the scale. This is not an auto range. If you're used to your fluke, this will drive you crazy. That actually looked... That is 192K, which is 200K. So bend the leads. 200K goes right here. R1. Bend the leads back. There we go. Resistors are in. This is going to go really quick. So we have a part with a very small label. We're done measuring these resistors, so I'll put that to the side. So the capacitors have very, very small writing. 222. So we need to find a capacitor that has 222. There's C3. I'll insert the part. Bend the leads. So we have an electrolytic capacitor at 100 microfarads. C5 is 100 microfarads. There's a strip that marks the negative, and that's the short lead. The positive lead is the long lead, and on the board, part of that is shaded, and that's the negative. So put the long lead in positive, the short lead in negative. Push that through. you want to hold it in place pretty good and bend the leads. There we go. These are probably the shortest parts on the board other than the electrolytic. I'm going to go ahead and solder all of these before I put any more on. So I'll chuck this in the hobby vise, Harbor Freight hobby vise. I'll put a link to the review of that. It's the first time I've used my soldering iron today, so I want to tin the end. The very tip where I'm going to be soldering, that will help with heat transfer. If you let the soldering iron sit, it gets scale on that tip and it impedes the flow of heat. So if you just keep it nice and shiny and tinned, and you want to wipe off any excess on a solder sponge. And I used a big solder for that. And I've got some very, very small solder that I'll use for the parts. Now, I like to do a part at a time, so I'll do this one. You want to use just enough solder to make a good mechanical and electrical connection. You want to do both sides of each component before you move on. That's my preference. I don't know how other people feel about that, but I want each part soldered in order. I'm just going to set the iron on the pad and the lead. I'm going to put the solder on the pad, and then I'm going to melt it. Okay, the board's busy. So I will clip the leads. There we go. So we've got all the capacitors, all the resistors. Okay, so now I want to go by height if I can. I want to do the transistors next. And I can't see the labels, so I got this magnifying glass, 9012. And if you spread these just a little, that tends to help. So 9015, and I'll look on the board and find 9015. There's only 3, so it shouldn't be that difficult. Well, there is no 9015. 9012. So there is a flat side of the component, and there is a flat side of the diagram on the board, and those match. So there's 9012, and I'll put this through. And what I do is I put pin 1 in, and pin 2, and then pin 3. Now I like to have these stand a little bit above the board. I don't like to push them all the way down. Maybe about 1/4 inch. And I solder these as I go. Too much chance of them falling out, and I don't want to bend the leads. And a little bit of solder will do you. And I'll check those with magnifying glass. Everything looks kosher so far. Put all 3 leads at once. There we go. So clip those 3. There we go. So we're down to 4 components. So going by height or proximity, the on-off switch just fits in these 6 holes. And you'll have to hold that in place till you get it down on the board. And then we just solder just like always. Okay, this is our variable capacitor, and that will set the sensitivity. And it goes right here, and you just place the, see how it has angled pins? So you kind of got to rock it back and forth until they all line up. There we go. And it's self-spacing because of those crimps. So we'll do it. So the component, now the way this is marked, the long lead is plus. You can see that plus, and then they have that. Now they put this cover on a piezoelectric. Typically with these components are soldered on with a solder bath, and they have to wash the flux off later. They want to keep this covered until after that bath. So peel that off. We're obviously not using a solder bath. So, okay, so in this diagram, positive goes up. So it goes on. We'll place it upside down, and solder it. There we go. Now, this is a close call, but I'm going to clip the plus. There we go. Now I need an LED. Okay, so we have the power connector. We'll just slip this into the power connector holes. Turn it upside down. Now this one is a problem because it's not going to sit flat, so I'll hold it with the iron. Solder the first hole. Then hold it until that solder hardens, and it'll hold it the rest of the way. Now the LED has a flat side over here, and that is the plus side. And I can't decide what type of spacing I want for that, so I'll probably go with more. I want that to stick up more. Might regret that later, but that's what I want right now. So I actually bend the leads on the back to hold it at that position. Chuck it into this. Solder it. Well, time to finish this. I've got all the components on. I need to supply power. I went and found a 5-volt wall wart that was off of an old cell phone, LG cell phone back in the day. I collected a bunch of these when they switched from 5 volt to 3.3 volt. I collected a bunch of the 5 volt. I stripped these off so I could test the power. So let's go ahead and do that. I'll set it on 20 volts. 5.16. I think that's pretty good for a 5 volt power supply. Sometimes it's not so easy to find a screwdriver to go down in those, but I managed to do that. So I'm going to raise these all the way up, make the hole as big as possible. Okay, so we've got plus on this side, negative on this side. I happen to know that this is red is plus on this one. Okay, I know from experience, a lot of the times when you turn these on, they're detecting metal. And there we go. Came on right away. So I'll take this and adjust the sensitivity so that it's not going off. Let's try a pair of pliers. Actually, okay with that. So this one has an LED in case you can't hear that annoying noise. So there we go. Now we got a little bit of cleanup to do. Okay, so the part's completed. It has an on-off switch and an LED to show as well as the noise. It has this adjustment for sensitivity, and we can adjust that. It's almost like a squelch. You turn it down until this isn't lit or you hear no noise, and then it will detect metal. So, MDS-60 from EQ Kit has an LED to show activity, a buzzer to show activity, an on-off switch, and a sensitivity adjustment. Other than that, it's a pretty basic circuit, almost exactly like the blue square one that I did. Nice little kit. Give you experience mounting parts. I'll draw out the circuit, publish it on my website if somebody would need the circuit. So if you like the videos, please subscribe to my channel. Thanks for watching.